Hello, this is Arushi Shah.
Hi guys, this is Pavan.
Hello, this is Pradyum Mohta.
Hello, everyone. Today, I will be presenting our team's project, a unique programming language we've developed called the Letter. I am joined today by my teammates Pradyum Mohta and Pavan. So, starting with the introduction, our language is designed with simplicity in mind, using single letter keywords to create a concise yet powerful programming environment. Project overview. The Sapien letter is very straightforward. We have replaced the traditional programming language keywords with single letters. For example, instead of writing int for integer declaration, we have used E as a letter or S for string, B for boolean. This approach significantly reduces code verbosity while maintaining functionality. Key features are strong typing, comprehensive data structures, clear syntax. So now let me walk you through the main features of our language. We support three basic data types, that is the integer, string, and boolean. We have implemented comprehensive arithmetic operations to control flow. We have if else statements, while loops, and for loops. The language includes function declarations with parameters and return values. We have also implemented various data structures, including arrays, stacks, and queues. String manipulation operations are available, including case conversion. Additional features, including constants, input-output operations, and a ternary operator. Let's talk about grammar components. The language syntax is built around these core components. The keywords are single uppercase letters like T for integer type and P for we support standard operators such as arithmetic, relational, and logical. The ternary operators use the standard question mark and a colon syntax. All the usual delimiters are supported, such as parentheses, braces, brackets, and semicolon. Moving forward, we would like to talk about architecture. Implementation follows a standard compiler architecture. The source code is processed by the Lexer. The Lexer would be generating tokens. These tokens are passed to the parser. The parser creates an abstract syntax tree, which is the AST. Finally, the runtime executes the program. The output is then generated. Moving forward, someone would be continuing with the presentation.
Now let's get into the implementation details. We have the Lexer parser and runtime environment, and the Lexer takes care of the token generation, character processing, and command handling. And the parser takes care of the abstract syntax tree creation, grammar validation, and error detection. And the runtime environment manages memory, scope handling, and it also takes care of operation execution. And next, we have lexical analysis. And the process here is first the source code is converted into stream of tokens and the characters are classified accordingly. Then tokens are generated and the final step is error detection. We have also implemented error handling so that we can avoid invalid characters, malformed strings, and unknown tokens. For example, let's take the source t x is equals to 5, which is basically integer x is equals to 5, where 5 is assigned to the variable x, and the tokens are type int for t, identifier for x is equals to integer literal 5 and semicolon. And next we have the parser, which generates the abstract syntax tree. It generates on the basis of node types, and the node types are declaration nodes, expression nodes, statement nodes, function nodes, and control flow nodes. For example, let's take the code tx is equals to a plus b, where the addition operation is executed, and the structure of the tree will be like the type integer, x is t is of the type integer, x is of the type identifier, and there's a binary operation. And a is an identifier and b is an identifier, which are on the left and right. Um, Now we have the key functions in runtime class, and the key functions are memory management and node execution. The memory management takes care of storing the variables, constants, and functions. The variables are stored in dictionary self variables. Constants are stored in self constants. Functions are stored in self functions. where each function has parameters and a body. And the node execution takes care of AST node, where it is handled by a specific method like execute assignment, execute print, execute function call, etc. Operations like binary operations, execute binary op, and control statements like if else loops and functions calls are also supported. And this is the execution and main flow of the program. And this flow chart shows us how a program runs step by step. It starts by receiving an abstract syntax tree from the parser. The program then goes through each part of the AST and checks what type of task is need to be done, like handling variables, performing calculations, or displaying values. If there's a function call, the program manages this code. If any errors happen during these all steps, they are sent to the error handling step. The program continues processing until it finishes this flow, ensures that the program works smoothly and handles all problems that come up. This is the main flow and execution of the entire program.
So now here is a snapshot of our coding language. So for example, we have this special test suite made for testing all the features of our language. As you can see, this is the basic coding in the syntax of our language, which tests for variable and its types, arithmetic operators, string operations, control flow, functions, arrays, stacks, queues, constants, input output, as well as ternary operator. So this test suite is divided into 10 parts, as you can see over here. Um, so when we run this file on the command prompt, this is the output which we got. And at the end, it shows test suite complete. So I will run this code and show you how the language is implemented at the end of the presentation. So now let's talk about the testing strategy. So our coding language tests using individual components, integration testing, error cases, and edge cases. So in the individual components, we can check via arithmetic operators, string operators, control structures. In the integration testing, we check functions with arrays, nested control flow. In the error cases, we test the array bounds, type mismatches, undefined variables. And in the edge cases, we check empty arrays, zero values, or boundary conditions. Next up is error handling. So the runtime checks for common errors during the execution, such as syntax errors are caught during parsing, runtime errors are handled during execution. We check for common issues like undefined variables, division by zero, and array bounds, which are array indexes which are out of bounds. So let me show you the demonstration of this language, how you can implement. So when you go to our GitHub repository, you can find everything in our repository with the our Lexer parser file, the runtime file, and the main file which compiles all of it. Other than that, under the data, there are all the test cases for each individual features. So you can download it, clone it into your device, and then put them in a function, and then we can run the language directly from the command prompt through the command line. For this demonstration, I will be using a test suite, which I already have in my laptop. So in the desktop, you can see this is our folder, which has the runtime, the main file, and the Lexer parser, and all the other testing test cases. And we have a complete test suite, which I showed you in the PPT in the start. So this checks for all the 10 features of our coding language. So since all of these are in a folder, we can directly open the command prompt. So here we will change our directory to desktop and then to the letter. So here you can, first you have to type Python, you need Python 3 for running this language. Then you have to call the Python file. And lastly, you have to name the text file which has your coding language. So you can just copy the name, paste it here. Now, when we click enter, the code runs and it has been made into each section, giving the output of each of the code, as you can see over here. It gives for uppercase, lowercase. In the control flow, there are if else loop, while loop, for loop. In the functions, you get the output. These are the arrays. Then there's stack and queue for constant, ternary operator, and some complex operations. So this is the input output. So I need to enter a number between 1 to 100. So I entered 55 and the double of it is 110. So the test suite is complete. Similarly, you can test for all the separate features with all the test cases which we have provided in our repository. So here is the link of a repository and the emails of each of us. So with that, we conclude our presentation of Letter, the programming language. So we have created a functional, efficient language that maintains power while reducing the verbosity. The source code is available in our repository, and we are welcome for any questions or your feedback. Thank you for your attention.